So this is a warm-up. You should have tried it ahead of time. Just try it, see what you can do. And now we're going to go through it, and so you can fix it, finish it, whatever. The graph of the function f above or to the right shows 6 line segments. So mainly they're just pointing out this is a piecewise function, right? It's not one line, not one curve, not one equation. So if you were to write it as a function, it would be piecewise. This is the graph of f. Cool. Now they want you to find G4, G prime 4, and G double prime 4. And G is this. You're like, okay, well, how do we find G if we have information about F? So the first thing you got to realize, I'm going to write this down. Gx is the integral of 0 to x of ft dt. So if you want to find G4, well, then you could, let me do it right here. No, we'll do it right here. If you want to find G4, then you plug 4 in. It's going to be 0 to 4 of ft dt. You don't plug the 4s in here. And that's a lot of times they like to use different variables here, where these are like really variables, and this is the variable that's tied to that. That just means you want the area under the graph from 0 to 4. And not just area, but like the integral. So if it's below, it's going to get counted as negative. And we got all of this. Now we could find each of these, make that negative, make this positive. You might realize that this is, these are congruent. So they're going to cancel each other out. So really we're just left with that. And, depends on how you want to find that. We're not going to find the antiderivative of f. We don't have, I guess we could, but it would be really complicated. But this is going to be, 2. This is going to be 1. The height is 2. So you could do a trapezoid, or you could do a rectangle and a triangle. That's totally up to you. Let's do the rectangle and triangle, just in case we need to break it up more later on. So this is going to be 1 times 2 is 2. 1 times 2 is 2, plus 1/2. 1 times 2. So you get 2 plus 1 is 3. So that's G4. Oh, okay. I can do that. Now they want you to find G prime 4. Well, how do you find G prime? Let's just figure out what G prime is first of all. That would be, it's the integral of f. So we have to take the derivative of the integral. And this is fundamental theorem of calculus part 2. So the derivative of the integral cancel each other out, but then you got to plug limits in. F of x, you got to do minus f of 0. You don't ignore the limits, but then you got to multiply by the derivative of what's inside, because that's chain rule. So derivative of what's inside, and that's 0, that cancels out. So we just get f of x. So the interesting conclusion here is that G prime x equals f of x. Okay, so that makes it really, now this is going to be a big deal for a bunch of things. Essentially, the thing you need to realize is that the graph of f is also the graph of G prime. So this is a graph of a derivative problem in disguise. It's very common. One out of the 6 Fourier response problems is going to be the graph of the derivative. Sometimes they just straight out tell you, hey, this is the graph of the derivative, the thing that we're going to ask you about. Sometimes it's a little more less clear. So G prime of 4 equals f of 4. So this is work you want to be showing. You want to show this. In fact, even writing something like this could get you a point. Not writing it could cause you to lose points. So you want to tie what you're looking for to the information they gave you in your work. G prime of 4 equals f of 4, and f of 4 is just the value of this graph. It's the y value is 0. So there's that. And then G double prime of x is going to be the derivative of g, which is going to be the derivative of g prime, which is going to be the derivative of x. And so G double prime of 4 is going to equal f prime of 4 is going to be the slope of the graph here at 4. Now the slope of this graph is down 2 over 1, negative 2. It's a line. So there you go. Now, this is kind of weird. This is probably, I think, the first time I've ever showed you guys something like this, but it's really common. They love to give you graphs, and they love to give you a new function as the integral of this other function on the graph. They love to do this. So you need it, you're going to start seeing these over and over again, and you should hopefully feel comfortable with them right when you see them. Does G have a relative min, relative max, or neither at x equals 1? Justify your answer. Now, generally, the way we justify relative maxes and mins is with the first derivative test for relative extrema. Unless we can't, for some reason, and we have the right information to do the second derivative test for relative extrema, we'll try and do first derivative test. Now, we're not looking for the relative maxes and mins everywhere. They just said at x equals 1, does G have a relative max or min? Now, F doesn't, but does G? Now, you know that, for a relative max or min to occur, it needs to be a critical point first, right? So does G have a critical point there? And yes, because we figured out that G prime equals F and F equals 0 there, so that's definitely a critical point for G, right? And we're going to need to write that down. Anything we draw in the picture is probably not going to get us points. So it is a critical point, and if this is the graph of G prime, then it's negative, it's decreasing, it's positive, it's increasing, it's going down, then up, then this is a relative min by the first derivative test. Using the way, using our ability to look at the graph of the derivative, we can figure those things out. So we're going to say that G has a relative minimum at x equals 1. Okay, well, how do you know? By the first derivative test for relative extrema. I mean, I would not abbreviate. I would not use initials. Maybe you want to use the full name. It's not just first derivative test. It's first derivative test for relative extrema. Okay, well, how does that test work? Prove it to me. You could say, well, G has a critical point at x equals 1 since G prime of, because G prime of 1, which equals F of 1, equals 0. So you still want to be constantly tying your knowledge about G to the information they gave you, which was originally just F. So I don't want to say G prime equals 0. I'd be like, well, how do you know that? Well, G prime equals F, which equals 0 from the graph of F. And G prime of X, which equals F of X, is negative, less than 0 on the interval negative 1 to 1, and G prime of X equals F of X is positive on the interval directly to the right, 1 to 4. That's what you want. That's a really nice answer, very well justified. We want to the first derivative test says if we go from a negative slope to positive slope, negative derivative, positive derivative through a critical point, it has to be a relative minimum. So you want to put all that evidence down. You want to say where these things are true at. That's your best bet. Okay, C says, suppose that F is defined for all real numbers, okay, and is periodic with a period length of 5. Periodic means it's going to keep repeating itself, kind of like sine and cosine and things like that. And if you look at this graph, you're like, yeah, that kind of looks like it could keep repeating itself, like it probably goes up and over and up and over here, and it just keeps going, is what they're saying. They said all reals, it's going to keep going, it's periodic. The period is length 5. Now, the length of period is the distance between where the pattern starts repeating itself. And you could look at any point. You could say, okay, from here to here, that's 5. Or you could even say from here to the same point over here, from negative 2 to 3 is 5. So you could look at any sort of spot in the pattern and find the distance to where it gets to that exact spot again, and that's the period. Okay, so they've told us that, and it's also clear from the picture. the graph above shows 2 periods of f. Okay. Given that g5 equals 2, which is something we could have calculated, I guess, but they're just giving it to us. Find G10 and write an equation for the tangent line to the graph of G at x equals 108. So let's do a couple things. Let's do one thing at a time. So they're saying that G5 equals 2, and we're looking for G10. And the easiest way to do this problem is to be like, okay, I have a known point on G. I want another point somewhere else later. I have information about the derivative of G. I don't have the original G function. I don't think you really want to find the original G function because it'd be crazy piecewise. So this is a perfect opportunity to use the first derivative tests. The fundamental theorem of calculus part 1, FDT part 1, which says if you integrate a derivative, I'm going to put gx here. If you integrate a derivative, you get the original function. And if you plug limits in, 5 to 10, use the one you know and the one you want, then those would get plugged in, and you'd get G10 minus G5, which I usually just leave that step out. But that's the idea. That's not something to memorize. It should make sense that integrals undo derivatives, and then you would plug limits in. So now using that, I want G10, so let's get G10 by itself. G10 is going to equal G5 plus the integral from 5 to 10 of G prime x dx. Now, G5 they gave us was 2, and the integral of G prime is also the integral of fx, right? Because G prime equals fx. And so we say, okay, well, we just need the area from 5 to 10. Now, they don't show that on the graph up here, 5 to 10, but they did say it was periodic, so it should be the same area as 0 to 5. So let's look at that. And you'll see this negative triangle cancels that positive, this negative cancels that positive, and all you're left with, if you want to integrate from 0 to 5, is that rectangle, because all the other parts cancel each other out, and you get 2. So G10 equals 4. This is all work you would want to show for response. You want to show your work. You want to show your ideas. Okay. And then the next question, which is separate, it says write an equation for the tangent line to G at x equals 108. So we need two things. We need a point and a slope. We have the x-coordinate of the point. We need the y-coordinate of the point. Now, the y-coordinate of the point is going to come from plugging in 108 into G. Now, we can use what we just talked about and say, okay, well, or we could just say, okay, well, G108 is going to be the integral of 0 to 108 of ft dt. And so that's the area under the graph from 0 to 108. Now, that's a big graph. It's a lot of graph. The thing that you should realize is that because it's periodic, you're getting the same values over and over again. Every 5 units, you're getting the same area again. So if we divide 5 out, and we get 21, and that means that you're going to get 21 whole periods of the shape, which we just found one period was value of 2. So there's going to be 21 periods that have an integral of value of 2. And then you're going to have a remainder of 3, which means you need to find the area from 0 to 3 here, which is also just going to be 2. And so you're going to get 42 plus 2 is 44. So there's your point. You have your point, your x and your y value. You need the slope. So you need G prime at 108, which equals f at 108. But since f is periodic, that means that, and using the same idea right here, that this is going to have the same value at 3, right? Because again, if we take out all the whole periods, 0 to 5, 5 to 10, it's that remainder that says, okay, we're going to have the slope right there. Now, the slope, now here's the deal. You might be like, oh, there's no slope because it's a corner, it's undefined, the two sides don't agree. Okay, but here's the deal. We're not trying to find the slope of f, we're trying to find the slope of g, which is equal to the y value of f there. The y value there is 2. So that's your slope, but this is all work you want to show. You don't just say, oh, the slope's 2. Okay, well, how did you figure that out? Okay, now we're going to write the equation tangent line y minus 44 equals 2 times x minus 108. And let's just leave it in point slope form. No reason to write it in slope intercept or whatever. Just leave it there. And that's it. So this is kind of an interesting problem. We haven't done one like this before, but it's very typical. So get ready to see it on practice tests and other assignments over and over again, that they give you a graph that you don't have an equation for. So you have to use things like finding the slope of it just by doing rise of run, finding the integral of it by finding the areas under the curves, making the negative parts negative. But then they give you this other function that's defined as the integral of that, which then turns this f into the graph of g prime. So, and when you justify relative maxes mins, you got to do it pretty thoroughly here. Name the test, name the way it works, and there you go. So this was a really good warm up, and that's it.